So, what we were talking about, let me try this. Ooh, yeah, I know. Okay, so we're going to start talking about solutions now. Remember, I told you that if you could make it through the stoichiometry stuff, the rest of this year is not going to be that bad, okay? I think you'll find the stuff we're doing to be, it'll make sense. It should be fairly interesting, you know, as interesting as everything else in chemistry is. Which it can be interesting, it can be not interesting. But point is, your next couple of units, the last two that we have before the end of the year, not going to be that bad, okay? So we're going to talk about solutions. So, well, let me take this off for a second. When I say solutions, listen up. When I say solution, that should remind you of something we talked about earlier in the year. But it's been a really long time, so I don't know if it will or not. If I say solution, what does that make you think of? I'm not even necessarily thinking about what we talked about earlier in the year, but if I say solution, what are you thinking of when you think solution? You think math? Okay.
Like a solution to a problem.
Okay, so that kind of solution. That's not what we're talking about here, though.
I'm talking about like mixtures.
Okay, so maybe a mixture might come into your head. And that's the context we talked about it in here. We talked about it in the context of mixtures. Okay, a solution is actually a homogeneous mixture. Do you remember that from earlier in the year where we said a homogeneous mixture can also be called a solution? You had to like take all those vocab words and figure out where to put them on the concept map. I don't know if you remember that or not.
Yeah.
Yeah. But it's stuck in your brain at least because you remember it. So, homogeneous mixture, okay? Now, this can be, most of the time in chemistry when we talk about solutions, we're talking about a solid dissolved in a liquid, but that's not always the case. There are lots of different types of solutions. You can't hear it on the video, but we got some loud yawning going on right now. Is everyone ready to proceed? Are we good? Okay. Even talking about yawning can make you yawn sometimes. It's weird. All right. So solutions, again, are a type of mixture, which obviously if it's a homogeneous mixture, it's a type of mixture. An example is a saltwater solution, okay? That's a very common example. Another common example might be Kool-Aid. Kind of one of my favorite solution examples. Not because I drink Kool-Aid, because I never do, but students always seem to like Kool-Aid. What? I didn't hear. Maybe do I not want to hear? Okay, I'll move on. All right. So the question is, what makes up a solution? There are actually two parts to a solution, okay? Those two parts are the solute, okay? Well, one of the parts is the solute. That's the substance present in the smallest quantity, and that's the one that dissolves in the other substance. So in the example of Kool-Aid, how do you make Kool-Aid? Yeah, you put that powder into water, right? It's a pretty simple recipe. So in that example, in the Kool-Aid example, what's the solute?
Sugar.
What is there less of usually? Hopefully. The sugar. Hopefully there's less sugar than there is water, right? Otherwise you're probably not mixing it correctly and it's going to taste, I don't know, way too sugary. So the Kool-Aid powder is the solute. That's also the thing that's being dissolved in the water, so we would call that the solute. Okay? Solutes can be gases, liquids, or solids. Okay? So usually the solute, like with the Kool-Aid example, the solute is a solid. It's just a powder, right? But it could be a liquid or a gas as well. Everybody good? The other thing in a solution is called the solvent. Okay, that's present in the largest quantity. And the solvent can be a gas, liquid, or solid. Usually it's either a liquid or a solid, but not always. So a lot of times we also say that the solvent is the thing doing the dissolving. So in the Kool-Aid example, what's the solvent? You knew I was going to ask it. It's water, right? If the Kool-Aid powder is the solute, then the water is the solvent. And that's how you make a solution, right? So when you go home today after school, if you feel like making Kool-Aid, you could explain to your family that you are making a solution, a homogeneous mixture of Kool-Aid powder and water. Kool-Aid powder is the solute, water is the solvent, and they have to be combined in the correct ratio in order to make sure that it's the proper concentration, right? And they'll look at you like, wow, you're really smart. That's what's going to happen. You won't get hit or anything. Yep.
I'm confused on the whole homogeneous and
Homogeneous versus heterogeneous? Okay, we've talked about that a little bit earlier in the year. Does anyone remember the difference between a homogeneous mixture and a heterogeneous mixture? You know the prefixes here. Homo means same, so homogeneous. It means it looks like one thing when you look at it. You can't see the parts, right? So when you have the Kool-Aid dissolved in the water, if you don't have too much Kool-Aid, right, if you put too much of the sugar in there, it sinks to the bottom. But if you don't have too much in there, it really just looks like one thing when you look at it. It's all going to be just a purple solution or a red solution. What's that?
like trail mix would be like heterogeneous.
Yeah, trail mix is a good example of a heterogeneous mixture because hetero is different, right? So you can see the individual parts. Salad dressing is usually heterogeneous. You can see different things in the salad dressing. So, you know, that's the difference between homogeneous and heterogeneous. Homogeneous is going to look like just one thing. Water is an example of the most common solvent. Water is really good at dissolving things, so it's just it's a solvent that we encounter a lot. And especially in this class, we're going to use water as a solvent for a lot of things. We already have this year. You just didn't know it was called a solvent. But a lot of the chemical reactions we have done have been with a solution, you know, something dissolved in water. Okay, everybody good? So the types of solutions that you can have. You can have a gas-in-gas solution, okay? Air is an example of that. The air that you are breathing right now is actually a solution by chemistry definitions. Seems a little weird, but nitrogen is the solvent, oxygen is the solute. Well, how do we decide that nitrogen gets to be the solvent? Well, when it's a gas in gas, it's a little bit, you know, the thing doing the dissolving. Maybe that's not the best way to define a solvent. But what's our other definition for a solvent? It's the one that's present in the largest quantity. Do you guys know what the percentage of nitrogen in the air that you're breathing right now is?
45.3.
That's a very specific guess, but not quite right. It's actually even higher than that.
81.
That's close. 78% of the air you're breathing right now is nitrogen. 21% is oxygen, and then the rest of it is just some other gases, just a few other trace gases. So because there's more nitrogen in the air, we call that the solvent. Oxygen is the solute. All right? By the way, it's really good that there's not 100% oxygen in the air around us. If we were breathing in 100% oxygen, it would kill us. So you need the oxygen to be diluted. When you get tired, you breathe from an oxygen tank? Well, when you're oxygen deficient, they will give you an increased concentration of oxygen, but you don't want to be in 100% oxygen for very long at all, because that will kill you. Gas and liquid, carbon dioxide and soda is a good example, okay? When you drink soda, there is carbon dioxide gas that's actually dissolved in that water. Okay. No, I don't know why people are packing up. We're going to finish this chart. 1 minute? Oh, yeah, you're right. I need to fix my clock. So it looks like we have 3 minutes. All right, I guess we're done for the day. We'll finish this. Well, we'll finish it a long time from now, but we'll keep going on Monday.